S-T-E.
S-T-U-A-R-T.
S-T-U-A-R-T. My stupid thing keeps throwing names in there.
Right. We're live now, so I'll go ahead and get into the show. Good evening, everybody. Welcome to tonight's show. My name is Stuart Davis, a flawed man of God. I am I'm a deacon at a small church just outside of Richmond, Virginia. I am not a pastor. I'm not a biblical scholar. I haven't been to seminary. I'm not trying to get you to join my church, and I'm not trying to get you to donate to any special cause. What I'm here to do is to talk about God, talk about faith centered things, talk about life, give you some insights into the life of a Christian and the topics and subjects that come out throughout the everyday, and give you a Christian perspective on it. I've been a Christian all my life. I'm not associated with any specific doctrine or denomination. I'm a non-denominational Protestant, and this is what we do here. We talk about God. We talk about things that make us that we believe in, and interesting topics that have things to do with that. And tonight, what we're going to talk about is our first real delve into the scientific side of Christianity. And we have a gentleman, a doctor, who reached out to me last week, who had something he wanted to talk about, and it was very interesting. So him and I had a phone conversation that went very well, and we scheduled it for tonight. And this is Dr. Vaughn Mancha. Dr. Vaughn Mancha, and he is going to talk to us about epigenetics, which is a somewhat new spin on how we understand the creation of, I guess, the changing of life, because we talk about evolution, and that's what the colloquial, the vernacular term is for how beings develop and how we get from the creation of life. So Dr. Mancha, epigenetics is nothing I've ever heard of before. Can you give us a brief explanation on what that is?
Well, the term epigenetics was coined by a gentleman by the name of Conrad Waddington back in the 1940s. And he noted that when he heated up fly larvae, they would develop a different wing pattern as far as the veins in the wings. And he realized that this couldn't have occurred by evolution, that there had to be something else going on that makes those different patterns show up under stressful periods. And he called it epigenetics. And there was initially some following to this, but people pretty much ignored it because it really didn't fit in with the way they understand evolution to occur. And they just kind of thought this was a one-off. However, in the last 20 years, really in the last 10 years, the field has just exploded. There's been 100,000 journal articles on this field. And the interesting thing is that epigenetics, and epi is from the Greek word above, kind of like epignosis, above knowledge, and genetics. In other words, there's little tags that sit on top of the DNA that tell it what to do. And this is not per the normal Darwinian ideas of mutations causing change. Rather, without mutations, it causes the same DNA to form different things. So that's, as a perfect example, if you look at the social insects like ants and bumblebees, they have different castes. You have workers and other things like that. How can it be that a worker who looks so different from a queen can be of the same DNA? There's no mutations. There's no Darwinism working there. And it's all because these tags play the DNA in different ways to give all these different forms. So this explains how we can have multiple different forms with the same DNA, and it explains a lot of things. How different looking. Well, for instance, one of the most startling example was when Darwin was on the Beagle and he went to the Galapagos Islands. He noted the different finches, how they had different beak size. And his idea was that random variation plus natural selection caused that to happen. but they've done 20,000 studies on those birds, and the mutations are really not there to cause that significant a change. Then somebody goes back about 6 years ago and they studied the epigenes sitting on top of the DNA, and it completely explains it. So basically, Darwin's finches were not caused by variation, random variation, and natural selection. It was caused by epigenetics. Well, I mean, that's where he started the whole theory, and his own choice birds were pretty much explained away by a whole new theory that's really come out in the last 20 years.
Well, and that's one of the things, if I understand a scientific method correctly, if you come out with a theory, it needs to be something that can be not only be observed, but also reproduced as well. And that sounds like the beaks, what you're saying is, this whole an institution, really, it seems like, of belief in Darwinism and a
Yeah,
natural selection and evolution, as we're taught in, I was taught in elementary school, or
yeah.
in middle school and high school. Um, None of this it was really even re,
It wasn't really known. It
never been
really
able to
wasn't.
reproduce it.
It wasn't known, but there was a lot of hints that should have had people looking in the right direction. A perfect example is a lady by the name of Barbara McCluskey, who lived in the 19. Her studies were in the 1950s, and you've been to a store, old country store, where they have the corn in the basket, and you notice that all the different kernels have different colors to it. I mean, these are the same DNA, and yet they have different kernels. And she was wondering what's going on genetically to make that happen. And she discovered that there's this stuff in our DNA called jumping genes, which are part of epigenetics, that are moving around to cause different forms to occur under stress. They ignored her. They thought she was crazy. They would go visit her and say either she's brilliant or she's absolutely crazy, because her thoughts did not fit in with the standard neo-Darwin viewpoints. Well, guess what? At age 83, she wins the Nobel Prize in medicine based on this, and everybody's quoting her work at this point. But they ignored it for 50 years. I mean, it's astounding. Their philosophical bent to try to make this theory called neo-Darwinism true made them put blinders on them. They really were ignoring these clues.
Well, that's one of the things we have with science, or with scientists, really. The portrayal that we're objective people, and everything we do is through this scientific method. But a lot of times, it seems like they get tunnel vision, and they want to believe something is right because it makes sense to in their mind, or it makes sense in their worldview, and so they just hyper focus on it, and so,
Yeah.
look, this has to be right. And then
Well,
what do we find out? Like what you're saying with Darwin is,
well, it's
a
not.
very key point on it was missed, the
Yeah.
ability to replicate what your observations. And then it's, like you said, he goes, well, there was a lot of warning flags there, but they just ignored them because they wanted it to be true, it seems.
Well, and a lot of different fields were doing their own thing, and they weren't communicating. They weren't cross-talking. I mean, you had the populational geneticists that were studying the DNA and mutation rates. You had the Evo Devo crowd, dealing with development and other things like that. And they were all coming to different conclusions, but they were still trying to shove it into the corner of neo-Darwinism to explain things. But subsequently, all bets are off now. And what this has caused is there was an article in The Guardian that said a third of biologists now question neo-Darwinism is explaining stuff. They don't want to believe in intelligent design. They can't do that. That's, anathema. But but at least a third of them realize their theory is deeply flawed. And that's incredible. I mean, these guys didn't come to this conclusion because of anything creationists were doing, or really even anything the intelligent design community was doing. They came to this conclusion because of those 100,000 journal articles that came out that were explaining these mechanisms that were not fitting into neo-Darwinism. And so they really don't know what to do. The theory is completely up in the air. And but the problem is this goes back to a 170-year-old book of Darwin, and everyone kind of plays homage to Darwin. I mean, they'll say, when you press them on it, they'll say, "Oh, well, he's a long time ago. We don't really follow." I said, "No, but everything that you did was founded on his original idea." And so they're distancing themselves from Darwin at this point, which is pretty sad. So,
I mean, and that's kind of the thing. It's just like, okay, well, if we establish our theory on x plus y equals 2, and we build this whole this whole belief system or this whole theory based off of this, and then you go back and you see, well, x is 1 and y is 2, so
yeah.
1 plus 2 does not equal 2. Now we have to go back and go, okay, all this is wrong, or well, that equation was wrong. It's like, well, no, but all of your expounding upon it has been built off of that foundation. That foundation is wrong.
I mean, this doesn't just happen in the field of evolution.
No.
I mean, I was just watching a thing about Alan Guth and his ideas of inflation of the universe, and there's another guy that also came up with inflation who completely disagrees with him. And the way they can shape their models, any way they want to make it look correct, but that doesn't mean that they're correct. Their models should be parsimonious and should be predictive, but their models are not predictive. And so, but the thing is that's only been an argument going on since the 70s, whereas this thing has been going on since the 1870s. And, they're really at a crisis point where they really need to just, change everything, really. And they realize that, but nobody really knows, where to go with things. So.
And you said that this stuff really started to pick up some steam in the 1970s. Epigenetics.
No, well, the first papers that were saying epigenetics is the way to go was in 1978. Mm-hmm. And it just basically said neo-Darwinism can't explain things. But epigenetics really started hitting in the 90s. And there was a few key researchers like Eva Jablonka in Tel Aviv who was really developing this initial work and telling everybody, hey, this changes everything. And everyone was like, oh, they didn't really want to believe her. No. But now, I mean, if you look at people like P.Z. Myers, who's one of the biggest flame-throwing evolutionists out there, he laments the fact that all his graduate students are leaving to study epigenetics. They don't, neo-Darwinism is going down in flames, and they want to go where the money is, because NIH will give you money to figure out epigenetically how that cancer occurred, for instance. And epigenetics explains over 90% of human illnesses. I mean, we're talking about actually making people live longer.
Right.
That's how significant this thing.
Well, you're starting to kind of crack that code, so to speak, because all right. So when we were talking, you had mentioned at some point that so we've got the helix, right? That we understand when we think of genetics, we think of the helix, we think of the little guy, the little cartoon in the Jurassic Park movie, and he's trying to explain the genetics and everything. But that's what you're thinking of, and now you're saying that there's a whole lot more out there.
Absolutely.
There's a whole lot more in that idea of genetics, but it's always been disregarded as junk.
Yeah, well, okay, that helix is a perfect example. There is this sense of we are just our DNA, and that our DNA plays us to what we are, and whatever we are is just because our DNA. But the epigenes sit on top of it to make us behave completely different. As an example, twin studies. There'll be one twin who may have schizophrenia or something else, or maybe homosexual, and the other one isn't. They have identical same DNA, but it's the epigenes that's causing those different behaviors. So, and it is very involved with behavior on many different levels. Yeah, that's actually one of the slides I sent you, and it basically takes the idea of the matrix, and you can see the A's and T's and C's, drifting down as though we're just reading those letters, and that's making who we are, and we are in a matrix, a behavioral matrix that we can't do anything about it. And that is so completely wrong. In that movie that you were quoting, they were talking about the DNA and we're in our DNA. Well, that's not it at all. As a perfect example, do you know that you have about 40 trillion cells in your body? And
I knew it was a lot.
And each one has about 6 feet of DNA in it. If you took it string to string, you could go to the sun and back 600 times. Okay, and 600 times to the sun and back, 93 million miles away. that all that information has to get packed up into 6-micron space in your nucleus. And guess what wraps it all up? It's all this epigenetic stuff, as well as other things that tightens it into a ball. Well, if it tightens it up that much, that means it's not going to get read without the epigenetics controlling what's going to get read, because it loosens up bits of the DNA at just the right time. So we were focusing on the DNA letters rather than how the DNA letters are played. And epigenes sit on top of the DNA to play it differently. It's kind of like a piano player. The keyboard would be the DNA. The fingers that go up and down play the DNA differently. In the same fashion, epigenetics does that. So we've been in a gene-centric view of things and all the entertainment that we see, and we're just kind of convinced that, we're doomed to whatever our DNA says of us. And yet the epigenetics sits over there to actually give us the real functional change, including our behavior, et cetera, to make us all very different. It's all epigenetic.
Yeah. I mean, we talk about, trillions of cells, right? And you're talking about how much DNA is actually in one of those cells. That's incredibly complex. That's amazingly complex. And we're talking, and when I start to think about that, when we look at the scientific understanding of the size of the age of the Earth, the way that mainstream science concludes that the Earth is, billions of years old, but the amount of time that mankind has been on the Earth, as far as science explains it, we're looking at hundreds of thousands of years.
Yeah.
And they don't know really where that, and they keep talking about what's that missing link and what. It just still doesn't seem like enough time, because you're talking about billions of years versus trillions of lines of code, DNA code, that has to be assembled and put in together into a being that doesn't even pop up at the same time the Earth forms and the cools, and it goes through all those cycles that science talks about.
Well, one of the interesting things is that there's a lot of ideas being put forward that when you look through the history of the paleontology, there are these periods where everything just seems to pop up all at once. The Cambrian explosion, many other different eras. And the neo-Darwinists are finally saying that, or a lot of them are saying, the neo-Darwinian theory just doesn't explain it. But some paleontologists are saying, oh, wait a minute, if we had epigenetics on top of it, that might explain it. So that's some area that they're trying to move into. Now, as far as epigenetics, the proteins that epigenetics come from, they can do the studies to see how far back they go, and they go all the way back. I mean, there's no, it's not like they suddenly pop into existence. As far back as they can see, they're there, and they've been completely conserved, which is always interesting. But how could something be completely conserved over billions of years, if you will? I mean, right. It's because it was made to stay there, and it has error corrections to keep it from changing over time. Because if it changes, everything goes for naught.
Right, and that kind of it really takes away from the argument that life is an accidental occurrence.
Oh yeah,
because it's almost like this is a mechanism that has been put into place.
You thought it was difficult when we just had DNA. It is now exponentially difficult now that we have epigenetics. One researcher said it's like you used to look in your electronic fuse box and the wires were all in the right places. Now when you look in there, it's just all spaghetti. It's bizarre. There's so much stuff going on, and it raises the level of irreducible complexity. It raises the level of just incredible design, and it's quite amazing. And it's not like here we've been working 170 years to kind of narrow it down. We're about to get it. No, it's blown wide open at this point.
Yeah, and so it's kind of the wild, getting into the Wild West, I guess, where everybody's kind of going out and exploring and trying to figure out what's going on.
Well, what's great about this? Big pharma, that's all they want to do is epigenetics now, because we realized that, you were talking about junk DNA. I was reading an article. Now they've realized that junk DNA has a lot of function this article was by cardiovascular researchers. They're in the lab and they don't have a big deal on whether it's evolved or whatever else. They just want to know what it is and what it does and how can we make money from it. And they discovered that the junk DNA, this particular junk DNA called long non-coding RNA, which comes from junk DNA, was the area that was affecting heart disease. And they said, he said, they made the statement, it was mislabeled. And what they were referring to was the Human Genome Project, which mislabeled it and completely bypassed 98% of the DNA. And here are these researchers saying we could have had another 20 years of research on this, but they mislabeled it. And the reason they mislabeled it was because neo-Darwinism said unless the gene produces a protein for natural selection to act, it can't be a usable gene. It must just be junk. You see what I'm saying? That's the ramifications of that simplistic point of view. And
it's building your house. To use the biblical term, building your house upon the sand. It's not as opposed to the rock, because you're not. It's not.
Yeah.
It's not good. It's not good science. Maybe
Francis
the assumption is made.
Francis
correct.
Yeah, Francis Collins spent $7 billion. And more importantly, he did 11 years of work to uncode that 2% of the DNA. And their account, you can Google it, Human Genome Project failure and the word failure, and you'll find 10 articles of people talking about how it was a failure. And Francis Collins went to a conference and said he himself was calling it refuge or junk in his first book, which was the Fingerprint of God or something. I forget the name of the book.
Right.
He actually pulled it out of his book to hide the fact he had done it. And he went to this conference and said it was the height of hubris to think that we could just label something junk when all this stuff is actually in there doing stuff. So it's like the light bulb went on. I will say one good thing came out of the Human Genome Project was the fact that they realized that neo-Darwinian principles of junk DNA were completely wrong. And another big lab called Encode went in there with over 400 investigators and coded out the rest of the junk DNA, and they discovered that at least 85% of it had function. So, which the evolutionists couldn't. They went berserk over that, and they criticized them. But now we are since Encode about 10 years out, and there have been 15,000 research projects based on Encode's data. 15,000. And not only that, they have 9,000 citations. And all these other guys that were just nipping in their heels, their articles were totally ignored. You guys are wrong. These guys are right. And we're going with the right guys. And so I would say actually the biggest disaster of neo-Darwinism was junk DNA. It cost us a lot. I mean, it cost us 20 years of research.
I mean, whenever there's that much stuff going on, it's difficult to me. And this is me as an outsider. I don't know the process, right? But to me, just as an observer would go, so you got like 90% of all this stuff you're looking at and you're just tossing it to the side. You don't think that that's there for a reason. I mean, we're very complex individuals.
Yeah.
But I don't know. So to back up, so let's back up just to get a better understanding of where you're coming from on things. You're a doctor. You're a medical doctor. You're not your background is not in genetics, but it is in biology and family practice and whatnot. And
yeah, I did a lot of clinical research. I was in over 40 clinical research trials, so I was studying the DNA of how things worked.
Right,
and so I had a little bit more than the average.
But this has become kind of a project for you since you've retired, and an interest, a hobby for you to.
Yeah.
So you've done a lot of research and education, and you have obviously you're a doctor, so you're well educated, and you understand where the stuff is coming from because you have that biological background and education. So, we're not just talking about somebody who's an archaeology doctor coming in here to talk about stuff. No, Dr. Vaughn, Dr. Mancha, he's been researching this thing quite a bit. It's been it's been a passion of yours. It's really what it seems like.
It's an obsession. I feel like I practiced medicine with leeches for 30 years because we really didn't know what was going on at the base of everything.
So you are so when we look about outlooks in Christianity, you are a man of faith. It appears to me that you believe in God and Jesus and all that stuff.
Yeah, I'm a non-denominational Christian, sola
Hey,
scriptura. Yeah,
now,
sola scriptura. If it's in the Bible, I
hey,
believe.
I
Yeah,
like that. Yeah,
yeah,
I do appreciate the sola scriptura um, doctrine, and but when it comes to just looking at some of the content that you have on your YouTube channel, and your YouTube channel is linked in the description below for folks if you want to check out more of what Dr. Mancha has done. He's got a few videos out there. One of them is a debate, and it sounds like that you are an old Earth creationist as
yes,
opposed
that's
to a
correct.
young Earth
That's
creationist.
correct.
So, um,
That's a small
I,
part of my life.
yeah, but
So,
it sounds like because you're an an old Earth creationist, that what you see in epigenetics points to or affirms what you believe about being about old Earth creation.
I wouldn't say that.
Okay.
No, I mean, no, because I mean, I believe going back to Adam and Eve, but of course, I believe that Adam and Eve may have lived somewhere around 100,000 years ago, and that's based on genetic study,
Hmm.
which was kind of interesting. About 20 years ago, they tried to figure out how we're related. It's like when you get a 23andMe test, down at the store, and they can check, basically compare your DNA to see where you diverged from. And according to their calculations, now they have different mutation calculations. Uh, John Stanford, for instance, who's a young Earth creationist and a geneticist, he uses mutation rates that puts man at about 8,000 years ago. But the other studies I tend to go with puts it at about 100,000 years ago.
Okay.
No, I do think epigenetics, looking all the way back, has been affecting everything. And I think epigenetics was very much involved with the original sin, for instance. Um,
And
but
that's where I was going to get. Where does epigenetics fit in as an affirmation to your core beliefs?
Well, this is not a widely held belief. In fact, I wouldn't say that, you know, Reasons to Believe or any of those organizations would agree with this. But,
Hmm.
um, in Genesis, it said, when they ate of the tree, dying ye shall die. Well, they died spiritually in relationship to God. But then they died 900 years later. So they didn't die immediately. And the reason they died was not because of eating of the tree directly, in my opinion. And the reason is God points it out. It said, if man eats of the tree of lives, he'll live indefinitely. So man was put out of the garden because of his sin. So, and subsequently, he was unable to get back to the tree of lives. I believe that the tree of lives had certain properties to it that probably helped the epigenetics of the human being to live longer. So, and they may have been in that garden eating of that thing for years and years, and regularly being resuscitated by this fruit. But once they were away from it, they started to age, and um, so that's their epigenetic profiles would have been better though than the average person today. Do you know there's been trials, actually, just one in the last year, where they took three different drugs, metformin, synthroid, and growth hormone, and they extended the lives of mice epigenetically and in longitude.
And
There are
by about what factor?
about 3 years they calculated
That's a long time for a
in
mouse.
human times. No, well, in human times,
Oh, okay.
I
Still,
mean,
3 years.
very long. There
I
are
mean,
trials going on right now to extend our lives by 10 to 20 years with the drug, an
right.
epigenetic modifying drug. And we know that epigenetics affects those parts of the body, like the telomeres and other things like that. So I would not be surprised that in the next 5 to 10 years that there's going to be some drug that pops out. It won't make you live forever, but it make you live, a good 10 to 20% longer, which is
Right.
significant if you think about it.
Yeah.
So if this could happen epigenetically with a pill today, it makes sense that this is probably going on in the garden with that tree, whatever it was. And
There is nothing new under the sun.
well, and the thing is when I was in medical school, I was thinking, what happened to Adam and Eve when they ate of the tree? Was there something in the tree of knowledge of good and evil that kind of poisoned their genetics or something? I said, it just doesn't make sense the way I understood genetics. But now that epigenetics comes along, it makes total sense of how that could occur. So I think it's an epigenetic thing that occurred. Of course, I'm the only one that I know of saying that.
Well, hey, US, come on. I think you've got some good things to say. So that's why you're on here talking. Give me your opinion on things. But what you're saying does kind of make sense in a way. You have the tree of life and you have the tree of knowledge. We can call it that.
Yeah.
When they eat from the tree of knowledge, they're cast out. Well, now they're no longer there with that the tree of life. And then
Yeah.
you've got several theories on the dilution of the blood. There are people who've Eric Roland, who comes onto this show bi-weekly. He's big into the discussions about Nephilim and how the sons of God have come down and kind of diluted the DNA. I think that's that's more of a supernatural explanation on things. But we get from Adam living, about 1,000 years, and we have several generations of that, to where we're at now, where we're, life expectancy hundreds.
Yeah.
Once you reach 100, you're pretty much at your expiration date. And,
well, what's interesting about the ark, of Noah, basically, they have done studies on the epigenetics of salmon who are in hatcheries where they have a bottleneck to their population, where they go to a small population, and they've studied the epigenes on them and noted that they are different, and those salmons do have shorter lifespan. So the same thing may have occurred in the ark when they truncated down, because I was trying to figure out through Mendelian genetics, how could that work, because it shouldn't have truncated down to cause them to age so quickly. I mean, the first people off the boat, the first generation, were living like Abraham, 150 years, 250 years, and then, down to 125 and down to 90, so epigenetics would explain that. Plain old Mendelian genetics would not explain that. So
now, where else do you see epigenetics pop up through the Bible or anything where in what God is saying? Where do you find that?
Yeah, one of the interesting things, like I mentioned that lady Eva Jablonka, who's in Tel Aviv, and I'm assuming that she may be religious or whatever, but I'm not sure if it was her or some of her people started to notice that when they did these experiments with rats, like for instance, they could give a rat a little shock to its foot and give it a citrus smell, and then its great grandchildren, they could give a citrus smell to it and it would start quivering. PTSD, basically. And they noticed that this was going on for 3 to 4 generations. And everyone said, whoa, 3 to 4 generations, where have I heard that before? And it's right out of Exodus 20. And what the interesting part about it too is we're starting to understand how it is that it seems like the sperm gets more of the bad epigenes when it comes to passing things on than the female does. So it says the sins of the father to the 3rd and the 4th generation. And the warning in Genesis 20 is that, if you hate me, I'll visit the sins of the father to the 3rd and the 4th generation. But if you love me, I'll visit loving kindness to 1,000 generations. But then it goes on to give the 10 commandments, stealing, adultery, these other things. All of these things cause a state of psychological stress when you get involved with it. It'd be like pornography all the time. You get addicted to it. And these things can affect the epigenes and get passed on through your children to the 3rd and the 4th. So I used to always think that was kind of an unfair thing. The father did something and he's punishing the 3rd and the 4th. That's not it at all. He was saying, look, here, I've given you 10 commandments to follow so that you won't do these sins of the father to be passed on to 3rd and 4th generation. What's interesting about this, and this is just kind of an aside, the Jewish people are people that have lived under the law longer than any other people group. And do you know that amongst Nobel Prize winners, the Jews only make up 2% of the world's population, yet they get 20% of the Nobel Prizes. I used to think that God just kind of, gave them this extra wisdom. when it could be that goes back to the Ten Commandments and them keeping it. They may have rejected the Messiah, but they still kept those 10 commandments. So,
Well, I mean, you can also, you also point to, the Jewish community. They're very insular in some ways, but they they have an incredible um, affection
yeah,
for educating. They want their kids to be educated, not just in the law or the Talmud and all the stuff that
yeah.
they learn, but also in many things. And
Well,
they
you
help
make it,
as a
you make
community. They
it,
help each other out, and so
yeah,
that's.
you make a good point there. They are really steeped in the Levitical laws as a child, so they
Mhm.
learn the logic of law. And I mean, I'm sure that's why a lot of Jewish people are lawyers. But also, that sort of algorithmic thinking helps you become a doctor or anything you want to be. So, yeah, just their tradition of that. So it may not at all be epigenetics, but
Well,
it may just be they follow the Mosaic law.
well, not well. I mean, and that kind of based on what you're saying. I mean, if the epigenes, or the epigenetics behind it is a reaction to our state of mind. If you've got a collection of people who are mostly emphasizing education
Yeah,
and look working in lucrative fields, that seems like it's just going to build on itself, because that kind
well,
of,
the,
if there's what God's saying about negative aspects, he's also talking about positive aspects
yeah.
too. So perhaps that's contributing to
Well,
genetics.
I will say that something may be going on epigenetically. There was a study of Jewish people in terms of the levels of autism and everything, and
Mhm.
they studied it epigenetically to realize that they have a high level of high spectrum autism. We're talking about the kind of autism that Bill Gates has. Just genius level people
Mhm.
based on it, and and it's an epigenetic thing. How it happened, who knows? But they do have a high preponderance of that. So you basically have a lot of nuclear scientists over there. Most of them serving falafels because they don't have jobs.
So we've got a pretty good discussion here, and what I had told people yesterday when I was talking about this topic coming up, was that we were going to do kind of a brief ish. We're almost at 40 minutes. A brief ish introduction and discussion about epigenetics, and then we could schedule another time in the near future where to do a more expanded and more prepared with visual aids and everything, where you
Yeah,
can kind of discuss the nuts and bolts of it, because I do find, I feel it's compelling. So I'd like to try to wrap this up with kind of a question of mine,
sure.
and we'll see where this goes. Who knows how long this will take? But where do, the one thing I always worry about in science is, it's boundless, right? Because the universe is infinite. God is an um, infinitely powerful being, and we see so much complexity, but at the same time, we kind of get ourselves in trouble with things with atomic energy. We've created a very powerful weapon and very powerful um, energy source. AI, we've created something to make a lot of calculations easier, but there's limits on how far we should go with AI before we create something that is self-destructive to us. What I see in genetics a lot, and especially what's kind of going on in China, where we're talking about homunculi and chimeras and that kind of stuff, where we're splicing genes and putting human genes into animals and animal genes into humans, and it's very concerning. Where should we be mindful or careful with what we're doing with epigenetics?
Uh, well, the biggest thing really is CRISPR technology. CRISPR was discovered in prokaryotes, or the most primitive forms of life, and it was basically like a computer virus thing that if you've ever had a virus pop on your computer, it's kind of like a bug shows up and said we're going to put it in quarantine. I used to always wonder, why put it in quarantine, why not get rid of it? Because it wants to keep that code and compare it against other code that comes along, and that's exactly what those cells are doing. And they realized this thing is very good at cutting right at specific areas and doing some other things. Now, our previous attempts at genetic engineering was kind of like viral, trying to insert a virus, but this CRISPR is so specific. I mean, it's right on the dot, and that's really where genetic engineering is going to come. And it's, will they also be able to work on the epigenetics with that? But that's really more of a genetic thing that could affect epigenetics. It's not so much epigenetics causing these sort of things, because the tags are so diffuse and difficult to lock down. But taking a stream of DNA out with a particular virus clipper like CRISPR's, that's where everything's going. But we have all these different organizations of ethics that we have to pass through whenever you do that. That's one of the things in the 40 clinical research trials. You had to know all the stuff of the ethics, the Nuremberg, all this sort of thing, so that stuff like that doesn't happen. And
yeah. I mean, you always worry about the places that don't care about that. Like, we talk about China; they'll do what they want to do whenever they want to do it. But it's kind of like when does our study of epigenetics and our application of what we learn from epigenetics, where might it start to enter in the realm of trying to play God with things? That's where I always.
Well, the thing is epigenetics does not change the DNA sequence. So you're really, when you start changing the DNA sequence of strands, you're getting more into the God aspect of things.
Okay.
And fortunately, it doesn't. So the things that we're trying to do with epigenetics, for instance, is there's so many cancers are caused by epigenetic mistakes, and they can put these enzymes in there that halt the epigenetic enzymes. But it's just kind of a drug that goes in there.
It's making us mo better.
Yeah, it's not a DNA clipping device. So
okay, it sounds like this is and look, that's what we say. There are good things with all of these other dangerous sciences that we deal with. With atomic energy is a great example, I think. But with epigenetics, we have, it sounds like, a good way of attacking diseases and increasing longevity and increasing our quality of life. I'm sure that dementia probably is, and some of these Alzheimer's, ALS, and all this the stuff that we see now.
If any, you can go you can put on Google epigenetics and whatever disease you're interested in, and you'll see countless articles on it. I mean, so it affects everything. It really does. There's a few things like single cell mutations, like sickle cell anemia or cystic fibrosis, not so much. But in general, most diseases have multiple genes involved, and the epigenes are controlling those genes. So epigenetics is involved with the vast majority of human illness.
Well, this is pretty compelling, Dr. Mancha, and I appreciate you reaching out, and I do think that we need to follow up with this with something a little bit more in depth. But I think this was a really good and refreshing kind of briefer way of attaching it. And you have a wealth of knowledge, I think, that is very valuable, and I think that people might really appreciate that. So with that said, if you like what I mentioned it earlier, if you like what Dr. Mancha is talking about, by all means, check out his YouTube page. It's linked in the bottom, and follow him there and see what else he's had to say on things, and tune in once more when we talk about this in the next week or two. I think when the good thing with Dr. Mancha, he's been the easiest guest I've had to schedule. He's basically, I'm retired, so whenever you want to do this. So that helps. If you like what's going on, if you like kind of the content of this show, by all means, like, subscribe, share this. I'm on Facebook, Twitter, YouTube, Rumble. Back on Rumble. Rumble wasn't working last night, so I didn't do it. But I'm back on Rumble. It was working today. At A Flawed Man of God. It's very easy. It's the same way across the board. And share this with anybody you think might be interested. And you can reach out to me and leave a comment. And I'm sure that Dr. Mancha will be looking for that on this as well. And Doctor, if you want, by all means, you can copy this broadcast and put it on your own YouTube channel. I do not care. It's not copyright is not necessarily the thing I'm worried about with the show. So with that said, everybody, tomorrow night is Friday. So we'll be back in the book of Numbers and reading. I don't have any guests lined up there. And we will go from there. But in the meantime, folks, you guys have a good night and God bless. Be safe out there.